Okay, so the thing we are discussing that the ransomware so lock the user out of their device and demands money to restore the user control. Ransomware that encrypts data on the phone and demands payment to decrypt the data again. Ransomware that leverages device policy and manager features and cannot be removed by the user. That means the user cannot remove that policy. So here mainly what the attacker takes the control of your device and demands money so that it releases the control. This is the ransomware attack. Okay, so this is of all the attacks we have seen. Now for classical encryption techniques, two classical encryption techniques are used, that is the substitution and the transposition. These two techniques are used. Substitution means what? Replacing an element, though you have not, I have only given you the, it is not on your syllabus also, that block cipher or hill cipher, that is not in your syllabus, but I am only saying the introduction of it. So mainly the classical encryption techniques is two techniques, that is substitutions and transposition. These two techniques are present. These two techniques are present. Now substitution means replacing an element of the plain text with replacing the element of a cipher text. That means really replacing the element of a plain text with the element of the cipher text. The same overall substitution rule may be applied to every element of the plain text. That means in plain text present and the characters in the plain text are replaced by the characters of the cipher text. Now this substitution rule may be applied to every element. Every element of the plain text, this rule can be applied. Or the substitution rule may vary from position to position in the plain text. That means this substitution rule can vary from position to position in the plain text, position to position. This substitution rule may vary. Now, transposition means what? Transposition means rearranging the order of the appearance of the elements in the plain text. That is what we are substituting. But transposition means rearranging the order of the appearance. Means rearranging the order of the appearance of the element of the plain text. We uses the transposition techniques. Now transposition mainly does, how we transposition do? Transposition is also referred to as permutation. Means it is what? It is a rearranging the order of the plain text or the appearance of the elements in the plain text. We are rearranging that appearance of the elements of that plain text. That is the transposition. Now transposition is also referred to as permutation, and transposition may be carried out after the substitution or the other way around. That means after substitution the transposition can happen, or the transposition happen first, after that the substitution be done. Now in complex algorithm, there may be multiple rounds of transposition and substitution present. The multiple rounds of transposition and substitution. Now it is not on, I am only discussing the basic, like how we do, I am discussing about that. So the first type of cipher, that is introduced are known as the scissor cipher. This is the first type of the cipher. And in this what? A character is replaced by another character in a set. Now how it can be done? It is the encryption in a character is replaced by the another character. Now which character we will choose? Simple English character. Simple English character, through this the encryption will be done. Let's say from the figure or from the drawing you are seeing, that there is a sender present. So the sender is sending a message that is saying, dear friend. It is sending a message, dear friend. Now, this is what this message is, the plain text. Now, after the encryption algorithm, after using the encryption algorithm, this message will be encrypted. Dear friend, this message will be encrypted. Now, how this encryption can be done? Let's say the encryption is done. It is the first cipher. So this first cipher is what? This is the previous time ciphers. The first cipher that is introduced, that is the Scissor cipher. So let's say the encryption is doing, that means all the characters that is present in this word will be converted by encrypting 3. 3 means what? That after D, what happens? After D, which characters is, after third position, which character appears? By for D, after D, E, F, G. So D, E, F, G. D is converted to G. E, after E, then after E, by third position, what character happen? E, F, G, H, H. So that means H. So like this, dear friend, by third position in the characters, we are replacing it. That means the character that is present in the plain text, the ciphertext character will be 3 higher. That means 3 position increasing that cipher characters, so that it will become the ciphertext. Now that means what? D. So after D, what happens? The 3 position, that is E, F, G. So it becomes G. E, after E, if we see the third position, then E, F, G, H, H. So H came. After A we see B, C, D. So that's why D came. So like this, with this key, it is encrypted and it become ciphertext. So GHDU, GHDU, IUL, HQG. And now in the decryption algorithm, we will subtract this 3. And if we subtract the 3 from this, then that means G. From G, the 3 element we minus. So this plain text will again come. Now, this will do by what? The receiver will decrypt this with the decryption algorithm, and the original message it will receive. Clear? This is the cipher text. This is the Scissor cipher. That means a character is replaced by another character in the set. Okay? Clear hai?
Yes, sir.
Okay. So this is the concept of the Scissor cipher. This is the basic concept. There is many other ciphers present, but I will not discuss it because it will be higher level thing. That Scissor cipher, another one is Hill cipher, another one is the Hill cipher, then Playfair cipher. So like this is the encryption techniques. This is the encryption techniques. Now you say this is the earliest cipher. That is what I have said, that this is the earliest cipher we will use. But this can be breaked by the attacker. This can be break. How breakable can be done? Because they do not know the frequency of the characters, how it is coming, it is not they know. Then how they can break? Now, you can use this information if you know the target of the language frequency count. So if you observe in English, character, E, T, A, O, I, N, S, R, H, D, L, U, C, M, F, Y, W, G, P, B, V, K, X, Q, I, J, Z. These letters comes maximum. The frequency of these letters are maximum. So that's why through frequency of the count or the frequency of the letter, by using the permutation and combination, the attackers break that. The attackers can break that encrypted message and know that they know the original message. What it have sent, they can able to know that. That is why this scissor cipher can be breaked. Now consider a cipher text like that after encryption, the plain text converted like this to the cipher text after encryption, like this, a cipher text came. Now attacker will do what? It will use the all fearsome statistical attack. That means it will from there, it will see the most count letter. So the most count letter is what? If you see in this, the most count letter which came is the R. The most count letter in this R appears very frequently. So very likely is one of the top frequency letter. Then they will not stop here. After finding out, they will not stop here. They will pick. Now this is the process that how the attackers attack and how the attackers know that how to from play ciphertext, they converted it and know the original message. So whenever in front of them the ciphertext will given, they will see whichever letter is very much frequently coming, that letters he or she will pick first. So that means in this, if we see that R is coming frequently, so it will frequently look over the frequency letter R, it will look over that. Then he or she will not stop here. He will pick out more letters that which is coming frequently. So he will see, again observe which letter is coming frequently. He will pick one by one, he will pick that. And after that, he will pick the common words. Example, da. He will frequently check the common words that is coming. And after that, like this, which gives like that, it will convert this total text, because first find what letter is coming first. So he finds that R is coming very much, then T is coming very much, then H is coming very much, like this. You will see that what letter it is coming, repeating maximum times. And from them, it will look what is the common word or which is the repeating every times. From that, you will what? You will see that he or she is able to convert this text, this ciphertext into the plain text. So this is the ciphertext, and by using this process, he or she is able to break that ciphertext, and he or she can this uses this original text now. So this is the concept. Okay, so this is how this can be done. This is how this can be encrypted, and from encryption that it can able to break that encryption and intended what message it received, he or she will able to use that. Okay, so this is about our how we can break the ciphertext by the attacker, how it can be breaked. This is what. Now next is in the security, that is the public key encryption. Now what is the public key encryption? Public key cryptography is also known as the asymmetric key cryptography. Whatever I discussed, that asymmetric key cryptography is what? That means encryption and decryption, we have two keys. For encryption, a key is used, for decryption, another key is used. That's why it is saying that asymmetric key cryptography. Now, public key cryptography is also known as the asymmetric key cryptography. Now, to distinguish it from the symmetric key cryptography, encryption and decryption are carried out using two different keys. Now, till now we know that what are these two different keys, but what are the name of these two different keys? The two key pairs referred to as the public key and private key. The public key and the private key. Now with public key cryptography, in the public key cryptography, I have said that in modern day, asymmetric key cryptography is used. Asymmetric key cryptography used, and there is asymmetric means two keys will be present, and one key will be present in the public domain. One key will be present in the public domain. So with public key cryptography, all parties are interested in secure communication. That means all the parties that are present, if they want for secure communication, they publish their public keys. That means all, let's say there is A, B, C, D, E, like this, the parties are present. And all they wanted to communicate with, all they communicate with secure communication. Then all will do what? They are using asymmetric key cryptography. So that means there will be, all the parties will contain public and private key. But what will they do? They will publish their own public keys. Now, that is done depends on the protocol which uses it. So let's say first we will see the public key cryptography, confidentiality. What is the confidentiality of the public key encryption? Now, let's say the communication is happening between party A and party B. Now, party A, if wanting to communicate confidentially with the party B, now if A and B two present and A wants to communicate with B confidentially, then A can do what? A will encrypt the message with B's public key. Now A has also public and private key. B has also public and private key present. Both have their own public and private key. Now, if they want to make communication confidentially, then A will do what? A will encrypt the message. That means the message it wanted to try to send B. That message, it will encrypt with B's public key. Now, you can say why it uses the encrypted message, why it you encrypt the message with B's public key. Now, such a communication is done because if the message is encrypted with B's public key, then the message can only be decrypted by B's using B's private key, because same type of thing should be there. So that's why if the message is encrypted with B's public key, that means A and B wants to communicate confidentially and no other can access that communication. So A will do what? Because every party's public key is present in the public domain. So each and every party can access that public key. So if A wants to communicate with public party B, then A will encrypt the message using the public key of B that is available on the public domain, so that B will able to decipher or able to decrypt that message, because B's public key is used. So related with the private key, it can be using the private key, it can be decrypted. So B's public key it is doing. So using the B's public private key, the message should be decrypted. That is the confidentiality. Confidentiality means that we want to protect a message from the eavesdropper. So the eavesdropper means that is the malicious user. That means between them, no one can access that message. So that's why A have encrypted the message with B's public key. So that using the B's private key only, that message should be decrypted. Now you say that if the message is, let's say the message that sent A is encrypted by the using the public key of B, can the message can be accessed by C? No, because it is not encrypted with C's public key. Only the particular public key is used, only that particular private key should be breakable. It should be, we can decrypt. So using B's public key, that means only using B's private key can be decipherable, or not on by using the C's our private key. So this is what the confidentiality means. Okay, समझ में आ रहा है?
Yes, sir.
Oh. This is the network security part of the confidentiality. Now, this is what we have written, that if A is wanting to communicate confidentially with party B, then you see, if you observe this diagram, I am erasing. If you see or observe this diagram, let's say that, let's say this is party A and this is party B. Now, A's private key that is present, that is here, and A's public key, that is, we have said that between private and public key, the public key is placed in the public domain. So public key is placed in the public domain. So A's public key is placed in the public domain. Here also the party B's public key is present in this public domain. Now, A will do what? The message it wanted to send to the party B. This message will be encrypted using the public key of B. Using the public key of B, the message is encrypted. And after the message is encrypted, this message go over to the party B using the unsecured channel. Now, this message can only be decrypted because B's public key used, that means only be decrypted by using B's private key. But B's private key is present only for B here. It is that is not used. B doesn't give it into the public domain. It is present to him only. So using this B's private key, the message will be decrypted. And after the message is decrypted, it will get the original message, whichever the party A has sent. This is the confidentiality. This is the working of the confidentiality. Now, another one is the authentication. So what is the authentication? When party A is wanting to send an authenticated message, let's say party A is wanting to send an authenticate message to party B, then B would do what? B would encrypt the message with A's own private key. Authentication means what? Authentication means that the recipient needs a guarantee that it comes from the identity of the sender. Then what is party A is wanting to send an authentication message to know that party B that yes, I am the party A. That is saying that yes, the message you are receiving, it is from B and I am the party A. That to know, authentication message should be used. Now, how it will be done? B would encrypt the message. The message, it is with using the A's own private key. And authentication means the recipient needs a guarantee as to identify a sender. So let's, if we see in the figure that party A is wanting to send an authenticate message to party B. So it will do what? It will send the message. The message is encrypted. Here the message is encrypted using A's private key. So A using A's private key, the message is encrypted. And after that, the message will be sent over the unsecured channel. Now the message will be received by the party B. The message will be received by the party B. Now how the party B will know that, how it will do to the message that it received, how it will decrypt. Now it will decrypt using the public key, using the public key of the party A, because public key is present in the public domain. All the parties' public key is present in the public domain. So the message which is encrypted by the party A, the message that is encrypted using its own private key, the message will go over to an unsecured channel and the message will be received by the party B. Now this message will, how this message will be decrypted? This message will be decrypted using the public key of A. Using the public key of A, the message will be decrypted and party B will able to know that yes, it is sent from the party A only, and he or she is the authentication user. So this is the authentication. This is the process of authentication. Doesn't mismatch the authentication and confidentiality, because process is same, only the keys are different. In that case, with using the public key, the message is encrypted. That means if B wants to communication, B wants from A to B, the communication should happen. Then A will do what? A will encrypt the message using B's public key, and after that, the message will be decrypted using the private key of B. But here, what happens? The message is encrypted. Now, here the message is encrypted using the private key of A. And after that, the message will be sent, and the party B will do what? The party B will, the message which is encrypted using the private key of A only can be decrypted using the public key of A. So that's why the message is decrypted using the public key of A, and it will know the original message. And this is the authentication, that yes, I am the sender and I am the A, party A. So party B will understand that the message is coming from only party A. So this is the authentication. So do not match it during the exam. Do not match it the confidentiality and authentication, because these two are different. Okay. Now, if we want authentication and confidentiality, if we want the authentication and confidentiality at the same time, then the public key encryption for providing both the confidentiality and authentication at the same time, this figure is used. You see, at both same time confidentiality and authentication. If we need authentication and confidentiality, then what we will do? Let's say party A and party B, two parties are present and they wants to communicate. Then you see the message, this message is encrypted using the private key of A. The message is encrypted using the private key of A. That means this is what? This is the using the private key of A. That means what? The message is, it is the authentication process. It is the authentication process. Using the private key, the message is encrypted. That means it is the authentication process. And after that message encryption, the message is again encrypted. The message is again encrypted using the public key, of B. That means this is the confidentiality process. So after that, the message will go over the unsecured channel and it will go to the site. So party B will do what? First, party B will decrypt the message. The party B will decrypt the message with using private key of B. That means using the private key of B means what? That means this is the confidentiality process. They are encrypting using party B, and then the message goes and it is decrypted. This message is decrypted by the party B. So using the party B's private key. So that is the first process, is the confidentiality. And after that, the message is again decrypted using the public key of party A. That means this is the authentication process. And after that, the original message we will get. So confidentiality and authentication are needed, and these are needed in same time. So same time, like this, it will happen. So like this thing will happen. So let's see what it says, that when confidentiality and authentications are needed at the same time, in that time we will do this like this. That first processing steps undertaken, A to convert, that means party A convert M into encrypted form of C. Then that means the encryption happens. So whatever the process, this process is like that. That what I have said and explain the process. That first, how using the private key of A, this is what? This is the confidentiality process. Private key the message is encrypted, and after that again the encryption is happened using the public key of B, and that means this is the authentication process. Sorry, this is the authentication process, and this is the confidentiality the party B. Using the party B will decrypt the message using private key of B. That means first the confidentiality is happened, and because this message is go, that means the first using confidentiality the message is decrypted, and then it will again decrypt using the public key of A. Using the public key of A. That means this is the authentication process. This is the authentication. So this can be done by authentication when the confidential and authentications are needed at the same time. Now, here it means what? Here it means that the encryption, 2 times the encryptions happens. You see, the 2 times it is happening. The encryption is happening 2 times. And now when the sender A is encrypting, so sender A, let's say sender A is encrypting his or message with its own private key. It is encrypting its own private key. Using that, you see, using its own private key, it is encrypting the message. That means it is authentication. And this step can be said as A putting his or her digital signature on the message. This time when owns private key, the message is encrypted using owns private key. Then this step, we can say that it is putting his or her digital signature on the message. His or her digital signature on the message. Okay. So today, this much, because there is something which we have left, that is the we will see the public private keys and the algorithms, RSA algorithms in the next class, the RSA algorithms, and this algorithm is used the public key encryption we will see, then Diffie-Hellman we will see in the next classes. Okay, so till now, do you have any question? अभी तक कोई क्वेश्चन है किसी का? डॉली, अनिकेत, निशु, पल्लवी, किसी का अभी तक जो ये पार्ट हम लोग देखे समझ में आया पूरा, जो है एन्क्रिप्शन एंड डिक्रिप्शन टेक्निक? ओके, तो नेक्स्ट दिन हम लोग वो वाला लेके डिस्कशंस करेंगे, जो हम लोग का जो नेक्स्ट हम लोग का टॉपिक्स है, ये टॉपिक्स का ही कंटिन्यूएशन रहेगा. तो आरएसए एल्गोरिथम, डीएस, एईएस, तो उतना तुम लोगों का सिर्फ आरएसए एल्गोरिथम जो है वही सिलेबस में है, बिकॉज हम अगर पूरा नेटवर्क सिक्योरिटीज जो है सब एल्गोरिथम्स दिखाने गए तो मतलब तुम लोगों का टाइम भी नहीं होगा और तुम लोगों का सिलेबस में भी नहीं. बट हम लोग क्या है, हम उसका डेफिनेशंस बता देंगे, तो अगर कुछ आया एग्जाम में या जो है तो उस डेफिनेशंस का ये लिख देना. बट पब्लिक की, प्राइवेट की और ये कॉन्फिडेंशियलिटी, ऑथेंटिकेशन, डिजिटल सिग्नेचर बहुत बहुत इंपॉर्टेंट है नेटवर्क सिक्योरिटी का. तो ये पार्ट हम कवर कर चुके हैं. नेक्स्ट दिन हम लोग क्या है, आरएसए एल्गोरिथम्स का पार्ट देखेंगे. ओके, सो थैंक यू एवरीवन. आई एम एंडिंग द सेशन.